ಶುರು ಮಾಡಿದೆ ಸರ್.
Yes, sir. Fine, sir.
ಸೊ ಗುಡ್ ಈವ್ನಿಂಗ್ ಆಲ್ ಆಫ್ ಯು. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು.
Namaste, sir.
ಇವತ್ತಿನ ವಿಜ್ಞಾನ ಪ್ರತಿಭಾಶೋಧ ಯೋಜನೆಯ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಪ್ರೊಫೆಸರ್ ಸಂದೀಪ್ ಶಾಸ್ತ್ರಾಳ ಸರ್ ಅವರು ಪ್ರಚೋದಿತ ಕರೆಂಟ್ ಎಂಬ ವಿಷಯದ ಮೇಲೆ ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದು, ಈ ಒಂದು ಪ್ರತಿಭಾಶೋಧನ ಯೋಜನೆಯ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಅವರನ್ನ ಸ್ವಾಗತಿಸುತ್ತಾ ವೆಲ್ಕಮ್ ಟು ಯು ಸರ್.
Thank you, sir. Thank you, sir.
ಸೊ ಅದೇ ರೀತಿ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ನಿರ್ದೇಶಕರಾದಂತಹ ಎ ಬಿ ಬಸವರಾಜ ಸರ್ ಅವರನ್ನು ಕೂಡ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತ ಮಾಡುತ್ತಾ, ಇದೇ ರೀತಿ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಆಯೋಜಿಸಿ ನಮಗೆ ದಿನನಿತ್ಯವೂ ಸಲಹೆ ಸೂಚನೆಗಳನ್ನು ನೀಡುತ್ತಾ ಬಂದಿರುವ ಈ ಒಂದು ಅಕಾಡೆಮಿಯ ಮುಖ್ಯ ಕಾರ್ಯನಿರ್ವಾಹಕ ಅಧಿಕಾರಿಗಳಾದಂತಹ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ನು ಕೂಡ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೀನಿ. ಹಾಗೂ ನನ್ನ ಎಲ್ಲ ಇವತ್ತು ಹಾಜರಾಗಿರ್ತಕ್ಕಂಥ ನನ್ನ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರನ್ನು ಕೂಡ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹಾಜರಾಗಿ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ಕೇಳಬೇಕೆಂದು ಹೇಳುತ್ತಾ, ಡಾಕ್ಟರ್ ಪ್ರೊಫೆಸರ್ ಸಂದೀಪ್ ಶಾಸ್ತ್ರಾಳ್ ಸರ್ ಅವರ ಬಗ್ಗೆ ಒಂದು ಕಿರು ಪರಿಚಯ. ಸಂದೀಪ್ ಶಾಸ್ತ್ರಾಳ್ ಸರ್ ಅವರು ತಮ್ಮ MSc ಪದವಿಯನ್ನು ಪಾಂಡಿಚೇರಿ ಸೆಂಟ್ರಲ್ ಯೂನಿವರ್ಸಿಟಿ ಆಫ್ ಇಂಡಿಯಾ ದಿಂದ 2010ರಲ್ಲಿ ಪಡೆದಿದ್ದು, so at present now is working as the head of the Department of Physics, Medical Excel Stream across Karnataka Basic Educational Services Private Limited, Basavanagudi, Bangalore. Sir has some key responsibilities of he has involved in training 11th and 12th students of NEET and board examination, and is involved in developing the content, setting question paper, preparing delivery plan, and also part of interview panel of faculty recruitment in physics department. And sir also has some previous experience. Is lecturer in Bapu Composite PU College, Yeshwanthpur, Bangalore during 2010 to 2013. And PGT in Army Public School, Orange Road, Bangalore during 2014 to 2014. And also physics lecturer in Personal Learning Center full time from 2014 to 2016. And working as head of the Department of Physics, Rashtrotama PU College, Tanisandra, Bangalore in 2016 to 2017. And also is involved in online tutor in person consent Connect Tutor Vista for 11th and 12th competitive examination session based on 2012 to 2015. Sir, I have some awards. MSc Project Award in 55th of Department of Atomic Energy Solid State Physics Symposium in 2010, Manipur University, Karnataka in December 2026-30 in 2010. And sir also got some academic prizes in Science Database Competition, National Day Celebration, Department of Physics, Pondicherry University in 2008. And oral presentation, National Science Day Celebration, Department of Physics, Pondicherry in 2007. Also, demo or poster presentation, innovation, biodecimal celebration of Department of Physics, Pondicherry University in 2006. Sir, extracurricular activities, invited talk, entered basics of Raman effect, National Science Day celebrations, Bapu High School, TVD Road, Yeshwanthpur, Bangalore in 28th November 2012. And also is involved as member Science Club, Department of Physics, Pondicherry University 2006-2008. And also member of Student Organization Committee Reflections, National Science Day Celebrations, Department of Physics, Pondicherry University 2006-2020. And sir published some public papers, ion beam studies of semiconductors, nanoparticles for the integration of Optoelectronic Devices, SVS, Nageshwara Rao. So thank you, all to you, sir.
Thank you, sir. Thank you so much. Yes, sir. Yes. Good afternoon, students. How are you all? Hope you are doing well. Today we'll just start with the basics of electromagnetic induction and why we have to study electromagnetic induction. If you observe in the day-to-day life, any electronic gadget, if you are able to observe, for that you require that source of electricity. That all that source of electricity you are actually producing based on the principle of electromagnetic induction. Now, if you observe starting why this particular concept of electromagnetic induction has been arrived. So if you understand in your fourth chapter, there is something called as Eyester's experiment you would have observed. So let me just give a brief part of this Eyester's experiment. If you take a one cardboard and if you connect one wire passing through this in a perpendicular to the plane, now if you join okay some iron, if you just pour some iron sprinklings, ಈ ಐರನ್ ಸ್ಪ್ರಿಂಗ್ಸ್ ಈ ತರ ನಿಮ್ಗೆ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸರ್ಕಲ್ಸ್ ತರ ಬರುತ್ತೆ. ಈಗ ಯಾಕಪ್ಪ ಈ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸರ್ಕಲ್ಸ್ ತರ ಬಂದಿದೆ ಅಂತ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಂಡ್ರೆ, ದೀಸ್ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸರ್ಕಲ್ಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ಯುವರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಅಂದ್ರೆ ಏನ್ ಅರ್ಥ ಆಯ್ತು? ಇಫ್ ಐ ರಿಮೂವ್ ದಿಸ್ ಕರೆಂಟ್, ನಾವು ಈ ಟ್ಯಾಪ್ ಮಾಡಿದ ತಕ್ಷಣ ಮತ್ತೆ ಈ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸರ್ಕಲ್ಸ್ ಅಲೈನ್ಮೆಂಟ್ ಏನೂ ಇರಲ್ಲ. ದೆನ್ ಅಗೇನ್ ಯು ಸೆಂಡ್ ಕರೆಂಟ್, ಟ್ಯಾಪ್ ಮಾಡಿ, then again they will be aligning in the form of what exactly? Concentric circles. So as long as there is a current, then surrounded by there is what exactly? Magnetic field. Then the question comes, how did you get a current? I'm getting a current because I have connected this to an external source. This source is giving me potential. This potential is developed across this particular length of conductor. So that is called as potential gradient. ಏನಯ gradient ಅಂದ್ರೆ anything varies with respect to the distance. That's a concept of potential gradient. Now finally, this particular cell what I have connected here, that is producing potential gradient, which I can call as EMF or electric field. This electric field is giving the magnetic field to me back. That is the reason I have the concentric circles. Okay, without this battery there is no electric field. When there is no electric field, you can never get a concentric circles. That's a simple concept. Now this was an experiment done by the Eyster. Let me see reverse. That means by giving the magnetic field, can I able to get that electric field back? That is what now people wanted to observe. So there are the two people who wants to observe that. One is called as Michael Faraday and one more is called as John Henry. Now let us try to understand what they have established. So what we have seen, a constant electric field is giving the constant magnetic field. Now what will happen to the reverse? That is what now I wanted to observe. So if you observe the Faraday's experiment, so Faraday has taken with the help of coil and as well as the magnet. So coil and the magnet. So imagine there is a coil like this I have placed in YZ plane, and whether there is any current or EMF is there, I wanted to observe. For that I have connected one very sensitive instrument, which you all know, that's nothing but your galvanometer. Then along this axis I have connected one bar magnet. Let's say this is north and as well as the south. Now, if you move the bar magnet, let us say, towards the coil. Now, if I observe here, what is the action and what is the observation? If I move the coil towards the galvanometer, so that means moving north pole towards the coil. And I could say this galvanometer has some deflection. Let us say this deflection is there in what exactly? Okay, towards the left side. Towards the left side. This time, I kept coil in the state of rest. Now I kept what exactly? Magnet in the state of rest. Now I kept the coil towards the what exactly magnet. Moving coil towards the north pole. Still I could see the deflection is continuing, and that is in the left side. Now you take move south pole. That means reverse the magnet. This is south pole. Now this is a north pole. Now you move the south pole towards the what exactly coil. So I could see this, the deflection has occurred on the right side. Now you do the reverse again. Okay, move coil towards the south pole. The same deflection I'm getting in the right side. Next time, what did I do? Okay, keep the coil and as well as the magnet in the state of rest. That means don't move anybody in the state of rest. And I could see here there is no deflection. So next time, what did I do? I moved coil and as well as the magnet, okay, such that distance between them is constant. And again, I could see there is no deflection. These are all some rough observations of Faraday's experiment and coil and as well as a magnet. Now, can any students can get a conclusion what would have actually happened here? In the chat box or in the audio, I don't mind. Students, are you there? What would have happened here?
ಅವ್ರದ್ದು ಸೌಂಡ್ ಎಲ್ಲ ಮ್ಯೂಟ್ ಆಗಿರುತ್ತೆ ಸರ್ ಸ್ಟೂಡೆಂಟ್ಸ್.
ಹೌದಾ? Fine. Yes, somebody has said that. Yeah, chat box somebody told.
Yes, sir.
Yes, okay. Moving magnet induce
Yes,
the current. Very
Yes,
good. Very good, Apeksha. That's true. What is the reason, Apeksha? Why it has to induce the current? What is the reason? Now, in this case also I told, right? Magnet here also it is moving. Coil and magnet, both of them are keeping together. Now here also magnet is moving, Apeksha, now, but still there is no current. So then if you say moving magnet will give the current, now here even moving coil also giving, but here it is not giving. Okay, induced EMF will come due to the relative motion between a coil and magnet. Very good, fine. So what? If I have relative motion, then why I have to get it? What would be the reason? So you're partly right, Basaraj. Okay, fine. Okay, fine. If there is an induced, relative motion, so what? What will happen? There is no varying magnetic field. Okay, that should be the criteria. So more than magnetic field, we will actually observe in terms of the magnetic flux. Now, magnetic flux is also similar to that of your electric flux. And electric flux means what will happen? There will be the flux lines. So magnetic field lines outside the bar magnet, it starts from south to north. Inside the bar magnet, it starts from, moves from where to where exactly? South to north. This is north to south. Like this it will be. Yeah. So if I take up this particular story, this is coil, this is magnet. Through this magnet, now imagine I did not move the magnet and as well as the coil. I could say hardly some 3 or 4 flux lines are actually cutting. Now, if I make them to move together like this only, that means the distance between coil and as well as magnet is still remains the same. When it still remains the same, then the number of field lines associated with the coil, what exactly will be the same? Now, either you move magnet either towards or away. Now let us see what will happen. When I move magnet towards, then obviously the distance between coil and magnet will be keeps on reducing. The number of field lines also will be keeps on increasing. So far there was a 4. When I bring closer and closer and closer, the number of field lines will increase. Then obviously there is a flux is continuously changing. When you move the magnet far away, the distance is keeps on decreasing. Now once again flux also will be keeps on decreasing. So that means when the flux is 0, I'm not worried. When flux is maximum also, I'm not worried. But the current, the induced current or whatever that current which we are going to get, that will come due to what exactly? The change in the flux. So now what is the reason for this change of the flux? Okay, as somebody said, the change of the flux will be produced due to relative motion. Relative motion between what and what? Coil and as well as a magnet. Now the question will come, is this coil and magnet are touching each other? No. So we learned when they touch each other, then I use the word conduction. Because they're not touching each other, then I use word ಏನು ಯೂಸ್ ಮಾಡಬೇಕಿಲ್ಲಿ? ಇಂಡಕ್ಷನ್. ಓಕೆ, ಯಾರು ಇಂಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಇಲ್ಲಿ? ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ is getting induced because of what exactly? Magnetic field. That's why the name is given as electromagnetic induction. That means because of the magnetic field, you are getting an electric field. That's why name is given as electromagnetic induction. Fine. This is an experimental results from Faraday's experiment, okay, which is the help of coil-coil experiment. After 1 or 2 years later, but of course, this fellow has tried independently from one more scientist. Okay, so his name is nothing but Henry. He is also trying to conclude, is it be possible or not? So Henry's experiment, let us try to observe. So Henry's experiment will be nothing but coil-coil experiment. Now what he's trying to do? So you would have learned in the 4th chapter, there is a hallows cylindrical portion I have taken, onto the top of which I have winded like this. Students, can you tell me what I have drawn now? What is this is known as? Guess quickly what it is known as. I have connected the battery and I have taken a coil. What's the name of this? You already learned. I wanted to see in a chart box before I complete quickly. Very good. Solenoid. So solenoid I have taken. And there is a plug key. So plug key is very important. Now here I have taken one more coil. Now this coil, now I am going to connect through again a galvanometer. Now There are the two coils, coil 1 and as well as coil 2. In coil 1, it is connected to the battery. When it is connected to battery, then it can produce its own magnetic field. That means you are not at all depending on the one more. So in physics ಅಲ್ಲಿ ಯಾವಾಗದು ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕು, ಫಸ್ಟ್ ಸೆಕೆಂಡು ಬೇರೆ, ಪ್ರೈಮರಿ ಸೆಕೆಂಡರಿ ಬೇರೆ. ಪ್ರೈಮರಿ ಸೆಕೆಂಡರಿ ಅಂತ ಯಾವಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂತ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. ನಿಮ್ಗೆ ಮತ್ತೆ ಮತ್ತೆ ಎಷ್ಟು ಸರಿ ಬರುತ್ತೆ ಇದು, ಓಕೆ, ಡೈಫ್ರಾಕ್ಷನ್ ಅಲ್ಲಿ ಬರುತ್ತೆ, ಇಲ್ಲಿ ಕಾಯಿಲ್ಸ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಪ್ರೈಮರಿ ಅಂದ್ರೆ ಇಂಡಿಪೆಂಡೆಂಟ್, ಸೆಕೆಂಡರಿ ಅಂದ್ರೆ ಡಿಪೆಂಡೆಂಟ್. ನಿಮ್ ಸ್ಕೂಲ್ ಎಜುಕೇಶನ್ ಅಷ್ಟೇ, ಫಸ್ಟ್ ಪ್ರೈಮರಿ ಎಜುಕೇಶನ್ ಅಂತ ಕರೀತಾರೆ. That means you are learning about sentence formation, alphabets, everything. After that, you are going to come to the secondary school. That means without this particular block of 1 to 5, you cannot come to the 6th, 7th, and ನೀವು direct ಆಗಿ ಬರಕ್ಕೆ ಆಗಲ್ಲ. That means those basics what you have learned from 1 to 5 is important. So secondary ಅಂದ್ರೆ ಯಾವಾಗಲೂ dependent, ಅದಕ್ಕೆ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. Primary ಅಂದ್ರೆ independent. Now if I observe here, this coil I'll call as primary because it can have its own magnetic field. But here there is no magnetic field, there is no current. That is the reason this is actually has to dependent on the other fellow. As it is depending, then I will call this as a secondary. Good enough? Now he is trying to do this experiment at time t is equal to t1. He closed the plug key. That means switch is on madidru, correct? At time t is equal to t2, he opened the plug key. Open ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ, plug key will be lifted ಅಂದ್ರೆ off. At time t is equal to t3, again closed. T is equal to t4, it remains closed. T is equal to t5, open. T is equal to t6, remains open. T is equal to t7, closed. ಈ ತರ ಇದೆ ಸಿಚುಯೇಷನ್. If you observe, so whenever I'm continuously on and off, if I'm doing like this, what did I observe? Closed to open. And I could see that galvanometer will have, let us say, some right deflection. As right ಆಗಿರಬಹುದು, left ಆಗಿರಬಹುದು, because that's how I'm going to connect the galvanometer positive negative polarity ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. Let's assume right ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. When he observed here, open to close, opposite deflection he got. That means left. When he is observed, remains closed and also closed. That means he did not change the position. This time, what exactly? No deflection. Then again, closed to open, just like this, I got right deflection. Now from T5 to T6, open to open, no deflection. Then open to closed, what will happen? I got the left deflection. This is an observation. Then what is my observation here? When it is remains closed, when it is remains open, there is no deflection. No deflection ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? There is no induced current. But whenever there is a closed to open or open to close, there is a induced current. Now, what's the conclusion we can bring? What could be your observations from this particular experiment? Anyone of you just type something? What will happen when I change the position of the plug key here? Imagine if I close the plug key, then I will get a current. When I will get a current, then this fellow will become like a solenoid. And you know, within solenoid, what will happen? You will get a uniform magnetic field. But at the edges, what will happen? Magnetic lines of force will be changing. So that's how it will be coming. Now, you observe here within the secondary, 1, 2, 3 lines are actually cutting. If you open, these 3 lines will become 0. Why? Because plug key is open means there is no current. Once again you close, this will become 0 to 3. Once again you open, this will become 3 to 0. Once again you close, that will become 0 to 3. Once again you close, 3 to 0. Like this, it is continuously changing. So once again, what will happen? Okay, the magnetic flux linked with a secondary coil is also changing. Whenever magnetic flux remains secondary coil is changing, then again what I'm going to get? Induced current. That means whatever the Michael Faraday's results I got it from the coil and magnet experiment, same results I'm getting from coil and coil experiment, which is given by whom? Your John Henry. That's a story. So finally, what's the conclusion you can bring? Whenever there is a change in magnetic flux linked with a closed loop, then there will be induced current will be produced. Okay, and this phenomenon is known as electromagnetic induction. Yes, somebody has replied, Ananya Nagaraj. Yes, change in magnetic field. Okay, that's right. More than magnetic field, I'm actually looking in the magnetic flux. Okay, so I think even before that also somebody told magnetic field, magnetic field. Okay, so later you will actually understand. Even though magnetic field can remains constant, but still you will get an induced current. So the most important point is the change of magnetic field is not important. Magnetic flux is important. Fine. So magnetic flux is equal to B dot A, like the way how you have written your electric flux in the first chapter, same story will be writing. So flux will be equal to magnitude of B into magnitude of A into cos theta. Sometime down the line, you'll understand. Keeping the field constant, even if I change area, but still what will happen? EMF will come. At the time, you cannot go through that answer. Change in magnetic field cannot be satisfied. Sometimes B remains constant, A remains constant. I can change the orientation. At the time, what will happen? Still, there will be EMF can be produced. That means either B has to change, or A has to change, or theta has to change, or any one of them, or all of them has to change. Doesn't matter. Finally, my logic is the flux has to change. Once the flux is changed, then what will happen? Induced EMF can be produced. So the most important point is the flux. That's good. Fine. Now, let us take about what is the experimental conclusions given by Michael Faraday, and he has observed this all his observations, and he made two statements. The first statement is we have already discussed, that is called as Faraday's first law, definition of electromagnetic induction. The second statement, the induced EMF directly proportional to how quickly you are doing the change of the magnetic flux. So that's nothing but directly proportional to d phi by dt. What is the d phi by dt known as? You are measuring the change with respect to time. When you measure with respect to time, then that is called as what exactly? Rate. So the induced EMF is directly proportional to rate of change of magnetic flux. So that is a story. So if I write the proportionality constant, I can get the number of turns n into d phi by dt. And if I write, okay, with a negative sign, minus n into d phi by dt. So what is this n I will be taking? This negative sign will be there. I can able to give, that's nothing but what exactly? Lenz's law. So what is this Lenz's law? What is this conservation of energy? That and all we'll see in the next session some other time when it will be possible. Now we will be observing this particular story. Okay, fine. So this is known as what exactly? Okay, second law. Now we will take about a few numericals and competitive exams and board exam based questions also, because nowadays if you observe even in your for 12th and as well as 11th, when first Roman 10 questions are given in the MCQ format, so learning even those kind of the MCQs will be double helpful to you. One is for board exams and one more is for the competitive exams. Let's discuss a few basic things in it. So first let me give a basic part. The magnitude of the induced EMF will be equal to n into d phi by dt. If I say the EMF will be equal to current into resistance, that's again from the Ohm's law. If R is nothing but resistance of that particular loop, then I can write N into d phi by dt. Then induced current I will be equal to N by R into d phi by dt. This is an expression for induced current. This is an expression for induced EMF. So well and good. If it is continuously changing, then I can do it. But if the change is not continuous, then I can do even average. This is instantaneous EMF will come. Then I can take about the average EMF will be equal to N into delta phi by delta t. Then same story, I will be equal to N by R into delta phi by the delta t. This is about an average current. So when the numbers are given to you, okay, so that you can calculate final flux minus initial flux, then you can able to do this one. When functions are given, flux is continuously changing with respect to the time, then you can actually differentiate and you can able to do this one. So we'll get a clarity, we'll solve a few of the numericals. So, and recall, current I is equal to the charge divided by the time, delta Q by delta T. So if I write delta Q by delta T will be equal to N by R into delta phi by delta T. So delta T will get the cancellation. Delta Q will be equal to N by R into delta phi. So ಇಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. ಏನದು? The charge flowing will depend on what exactly change in the flux, but not in terms of the time. ಅಂದ್ರೆ ಸರ್ ನಾನು ಎಷ್ಟು ಫಾಸ್ಟ್ ಆಗಿ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? Then you will get a more current. But if I do slowly, then you will get a less current. But charge ಎಷ್ಟು ಫ್ಲೋ ಆಗುತ್ತೆ that is constant. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. I is equal to delta Q divided by delta T. Now if I take a coil like this, and if you bring a magnet, this is north pole to south pole. If you bring like this, now if you put a galvanometer, some charge will flow through the circuit. If you bring so fast, then what will happen? Same charge, that is 2 coulomb or 3 coulomb, whatever it is, that will move in so quickly. Okay, imagine it is 2 coulombs only. So 2 coulomb per 2 seconds. Then you will get what exactly? 1 ampere. If you do so fast. Now, I have done very less speed. Then charge transport will still remains the same. I have taken some 20 seconds. Then how much I will get? 0.1 ampere only. Very important point. So, your induced EMF and as well as the current depends on how quickly you are doing the change in the flux. But the induced charge does not depend on the time. Andre, how much ever the fast you do or how much ever the slow you do doesn't matter. What will happen? The total amount of the charge remains constant. That's an important point. Is that clear, students? Yes. Good enough. Now, let's take a few numericals. The flux linked with a coil changes with respect to time 3t square minus 2t plus 5. And the coil has the 2 number of turns. The resistance of the coil is 2 ohms per turn. Then calculate the instantaneous current at t is equal to 2 seconds. This is a question. So, what is to be done now? So I'm supposed to calculate what? Instantaneous current. Just now I have seen instantaneous means now should I take about differentiation or should I take about final minus initial? Should I calculate at time t is equal to 0, at time t is equal to 2 and to do it, or should I take the differentiation? Quickly, somebody can type to me. Can somebody type the answer quickly? Should I take differentiation or should I take an average value? Differentiation. Very good. So now I can get I is equal to I is equal to E divided by R. So I can write 1 by R into E. E is equal to, just now we have learned, N into d phi by dt. So I can write 1 by R into N. If I differentiate phi with respect to t, how much I will get here? This term will become 60 minus 2. This is term. Now, students, can you tell me what should be the resistance I'm supposed to take here? R? Should I take 2 ohms or 1 ohm or 4 ohm? How much resistance I should take? 4 ohm. But I have given only 2 ohm per 1 turn, right? Why I have to take 4 ohms?
Nikhil got to put 5 ampere, sir.
Sorry?
Nikhil got to put 5 ampere.
Yes. Okay. So you have to get what exactly the number of turns. How many number of turns I have? 2. And resistance. Resistance, we have to take the total. Understanding? So here I can write about 6 into 2 minus 2. Okay. Nikhil told it is 5 amperes. Okay. Is it right? Can you please verify, somebody? Yes, exactly. That's right, Nikhil. Good. Now, if I can give you about a similar question, so try that. So there is a uniform magnetic field of 3 Tesla, and it's going into the field like this. And I have taken one circular loop. Okay. This circular loop area is equal to 3 centimeters square. Now, about this axis, I have rotated by 90 degrees. I have rotated by 90 degrees. That means about this axis I have rotated by 90 degrees. Then what is the induced EMF? Now can you try? Nikhil, can I get an answer from you now? Zero. Harshita. Yes. Why is zero, Harshita? Can you give me a reason? Yes, Harshita is right. In fact, if I write this point A, B, C, D, this is the original point. It's not about cos 90, Harshita. Observe carefully. Now, first, here, I'm not giving about your flux varying with respect to time. Magnetic field is constant. Now, E is equal to N into delta phi by delta t. This is the story. That means now I have to do phi 2 minus y1
ಹರ್ಷಿತ್ ಅವ್ರ ಜೊತೆ ಮಾತಾಡುವ ಸರ್ ಲೈನ್ ಅಲ್ಲಿ ಇದ್ದಾರೆ.
divided by t2 minus t1. Yes.
ಹರ್ಷಿತ್ ಅವರಿಗೆ ನಾನು ಇದು ಮಾಡಿದ್ದೀನಿ.
Yes, sir. Yes, sir. Yes.
ಹರ್ಷಿತ ಮಾತಾಡಿ. ಹಲೋ.
Harshita, can you speak? Okay, fine. No problem. So if you can connect, no issues, you can speak. Otherwise, you can even chart this one. Now, let me take about the flux now. Flux is nothing but B into A into cos theta. What is theta? Theta is angle between B and as well as the A. That is the theta. Now, I know that magnetic field is kept into the plane that is along the z-axis. Magnetic field is kept in which direction? Along the z-axis. Now, if I take the area, what is the direction of the area? Many students will think that area direction is nothing but the plane. No, area direction is always perpendicular to the plane. This coil is already in XY plane. Then area direction will be in which direction you will get? Outwards or inwards, depending on what is that orientation you are going to take. Now, if I take outwards, then theta will be equal to how much you will take, either 0 or 90. Fine. So if I write as 0, then initial flux will be equal to how much I can write? dA. Now, after that, what did you do? You are rotating the coil about this particular axis. About this particular axis by 90 degrees. Then what will happen? I will get A here. Then I will get the B here. Then I will get the C here. Then I will get the D here. Now we calculate again a flux 2. Magnetic field is not changing. Effective area is also not changing. And did you observe the theta? Once again, this is the direction of the area, because area is not changed. Direction, because the plane is still remains the same. Perpendicular to the plane is area. And even magnetic field also remains the same. So once again, I'm going to get what exactly? Cos 0 only. So flux is what? BA. So BA minus BA will be equal to how much exactly? 0. That is what starting I told. When somebody has replied, in case of the coil experiment, what is the reason for the induced current? You told us, sir, change in magnetic field. I told at that time, we are not interested in magnetic field. We are interested in the magnetic flux. I gave you an example also there. One point. Though now this time field is there, but still what will happen? Though field is there, but flux is remaining constant. That is why you are not able to get what exactly the induced current. That is the important point. Is it clear to everyone, students? Yes. 1, 2. 2 students told. Fine. Then I'll assume everybody. The same question now let me try. Same question now let me try. This time I'm rotating about the diameter AC by 90 degrees in 2 seconds. In 2 seconds, understanding? Then I will add the resistance of the coil is going to be what exactly? 2 ohm. Okay, resistance of the coil is going to be the 2 ohm. Then what is the average induced EMF? And what is the average current? And what is the total amount of the charge has been transported? I'll now wait for 2 minutes. Let me see anybody is going to solve. What is the difference I made? So for the axis was perpendicular to the plane. Now I change the axis is vertical diameter, that is AC. By 90 degrees I have rotated. Try. Anybody? What is average induced EMF? Okay, I'm sure everybody would have tried. Let me do the same story. First, let me calculate the first flux, B1. So magnetic field is B, area is A, and theta. So cos of theta 1. So B is how much I have? 3 Tesla. Area is equal to 4 into 10 power minus 4 into cos theta 1. What is theta 1 now? Angle between area and magnetic field. So the area direction I can take what exactly? This is a plane and the area direction will be outwards, then or inwards, then magnetic field also will be what exactly in the same. Either you can take 0 or 180. Let me take as 0. So I can write as what exactly? Cos 0. So I can write 12 into 10 power minus 4 Weber. Now you said you have rotated about this diameter. When you rotate about its diameter, what is the situation now? It will be like this now. Because this is a ring which you have. The ring is there. Now we have rotated. So if you rotate, it has become like this. Now, the direction of area, what will happen? See, try to understand. This was a coil, imagine. This was the area. Now, about this point you have rotated. When you rotate, then what will happen? Even area direction also will be changing. Now, area direction is there along the which axis? X-axis. Magnetic field is there along the which axis? Z-axis. So what is an angle now? It's going to come. Magnetic field still I did not change. So BA into cos 90. So cos 90 will be equal to how much? 0. Then average induced EMF will be equal to N into delta phi. Magnitude only I'll take. So phi 2 will be 0. Phi 1 I will be taking. How many number of turns I did not give? 1. This I can write as 12 into 10 power minus 4. EMF will be equal to in the form of volts. Then if you want me to write I is equal to EMF by, okay, sorry, delta phi by delta t. By how many seconds I take? 2 seconds. So I will get 6 into 10 power minus 4 volts. Then I is equal to E by R. E is 6 into 10 power minus 4 by R. Resistance is 2. 3 into 10 power minus 4 amperes. Now you want charge. So I is equal to delta Q by delta T. Then delta Q will be equal to I into delta T. What is I? I have 3. And this fellow will be equal to how much I have? Then 2. Substitute. So you will be getting your charge. That is the story. So 6 into 10 power minus 4 Coulomb. Any doubts? Students, is that clear? Did you understand when I rotate how that area has been changed? One, two, three, four. Oh, good. Fine. 5, 6. Oh, very good. Very good. Fine. Good response. So this point you should be very much careful. So once again, the change of magnetic field is not important. The change of the flux is important. Point number 2, area. Area direction is always perpendicular to the plane. That point you need to be very much careful. Next, try one more question. The variation of flux linked with a coil with respect to the time is measured in 5 equal intervals. First interval is A, second interval is B, third interval is C, fourth interval is D, fifth interval is E. The variation of the flux with respect to the time. Variation of flux with respect to the time. Now, you have to, okay, if the induced EMF, okay, in the interval, first interval is EA, second interval is EB, third interval EC, fourth interval ED, fifth interval EE. Now, you have to identify the connecting relations, magnitude of the induced EMFs. So if I write option A, so EA is equal to EC greater than what exactly? EB greater than ED is equal to EE. EB greater than what will happen? ED is equal to EE greater than EA greater than EC. EB greater than ED greater than EE greater than EA greater than EC. EB greater than ED equal to EE greater than EA is equal to EC. So you have 4 options. Now can I just try which option would be right? Option D, Sudeep. Okay. So Sudeep said option D. Kiran also said option D. Is it right? Fine. So whenever the graph concept based questions will be given, you should understand only 2 points. One is slope and one more is area. Slope represents variation of y-axis by x-axis. Area represents product of y-axis to x-axis. Do you remember? Slope is nothing but delta y by delta x. Area represents what will happen y into x. That's the story. So in terms of your delta y by delta x is for average value. For instantaneous value, it will be equal to what will happen dy by dx. That's the point. Now if I write the induced EMF is equal to n into d phi by dt. So EMF is directly proportional to d phi by dt. So d phi by dt. Now I understand d phi by dt represents the slope. In the first case, it is actually touching the x-axis. So slope will be equal to 0. In the third case, it is parallel to x-axis. So slope will be equal to 0. Now, the region of D and E are part of a same straight line. When they are part of a same straight line, then what will happen? Slopes also has to be equal, because straight line means it's a locus of all the points which have the same slope. So you can able to tell here slope of D is equal to slope of E. Then the only odd one here is D. Now if you observe, this could be the flux has been changed from 0 to 5. Now if I calculate slope of B, y2 minus y1 will be equal to 5. X2 minus x1 will be equal to 1 time interval 5 by t, because time intervals are same. When I calculate slope of D, the flux changes again from here to here. So the change of the flux is still 5. But the time interval, if I write from here to here t, from here to here t, then I can write what exactly 2t. So clearly I understand I'm interested only in the magnitudes, not in a sign. So that's why I'm not taking what is positive slope and negative slope. The flux of B I mean, slope of B is greater than that of the slope of D. That is why B should have the highest. Fine. Next, where I have 0, A and C, those should be at the end. So this is ruled out, this is ruled out, this is only correct possible answer. So answer is D. Is it clear, Shivraj? Is it clear to everyone? Good. Next. One more question we can try. A conducting loop of resistance capital R and radius small r. A conducting loop of resistance capital R, radius small r, has its center at the coordinate system, center of the coordinate system. This is y-axis, this is x-axis, this fellow will be at the horizon, which is going to be the center. When it is rotated about y-axis, when it is rotated about y-axis by 90 degrees, the net charge flown in the loop is proportional to capital R power minus 1, second option capital R, third option small r cube, fourth option small r. So what is that you're supposed to calculate? The net charge flown in the loop is proportional to what? Yes, now can I get an answer? Sudeep and who is that? Kiran Gowda has given before. So let me see now who will give it. Okay. I is equal to n by r into delta phi by delta t. I is nothing but delta q divided by delta t will be equal to n by r into delta phi by delta t. So delta t will get the cancellation. Delta q will be equal to n by r into delta phi. Now, what is the delta phi? Let me calculate flux of 1. So what is that flux formula? I can always tell BA into cos theta. When I calculate the flux of the 1, magnetic field is B, area will be equal to pi r square and theta. What is a theta? Now it is kept in this format. Then what will happen? So magnetic field is like this. Then area will be in this direction. So then what I can write about cos 0? So cos 0 will be 1. Then I can write B into pi into r square. Now if I write the flux of the 2, just now I have seen when you rotate about the y-axis, now the coil will be like this. The magnetic field is still along the z-axis. Now the area of the coil will be there along the x-axis. So I can write B into pi into r square into cos 90 I will take. Cos 90 will be 0. Yes. Now if I write the delta phi value will be equal to B into pi into r square. This is delta phi. Now come back and substitute. So delta Q will be equal to N by R into B into pi into R square. So it is directly proportional to R square, but I have R cube and R. This option will not work, but it is inversely proportional to resistance power -1. So that should be the answer. Okay. Nikhil has given this time. No, good enough, Nikhil. Yes. Is this clear, students, to everyone? Okay. Yeah, it's 5. Maybe I think we can stop. Yes. How did you feel this class? Was it useful? Okay. Good enough. Yes. Yes, sir. Thank you. I think as you suggested, I'm just winding up but by 5.
Can I stop now, sir?
Sorry, sir?
Can you stop now, sir?
Yes, sir. Yes, sir. Definitely. Yes, sir. Yes. Thank you so much, sir. Thank you.
Thank you, sir. Thank you very much. ಪ್ರಚೋದಿತ ವಿದ್ಯುತ್ ಎಂಬ ಶೀರ್ಷಿಕೆಯಡಿ ತಾವು ಕೊಟ್ಟಂತ ಉಪನ್ಯಾಸವು ಮಕ್ಕಳಿಗೆ ಭಾರಿ ಸರಳ ರೀತಿಯಲ್ಲಿ ಕನ್ನಡ ಹಾಗೂ ಇಂಗ್ಲಿಷ್ ಎರಡರಲ್ಲೂ ಕೂಡ ತಿಳಿಸ್ಕೊಟ್ಟಿದ್ದೀರಾ ಸರ್. ಜೊತೆಗೆ ಹೋಮ್ಸ್ ಲಾ, ಐನ್ಸ್ಟೀನ್ ಮತ್ತೆ ಅದ್ರ ಜೊತೆಗೆ ಕೆಲವೊಂದು ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳನ್ನು ಕೂಡ ನೀವು ಸಾಲ್ವ್ ಮಾಡಿ ಅದ್ರ ಜೊತೆಗೆ ಮಕ್ಕಳ ಜೊತೆ ಇಂಟರಾಕ್ಷನ್ ಆಗಿ ಸೊ ಐ ಆಮ್ ಆಲ್ಸೋ ವೆರಿ ಹ್ಯಾಪಿ ಸರ್. ಮಕ್ಕಳು ಯಾವ ರೀತಿ ಅವರು ಖುಷಿಯಾಗಿ ಇಂಟರಾಕ್ಟ್ ಆಗಿದ್ದಾರೆ ಸರ್.
Yes, sir. Yes, sir. Yes, sir. I could say it. Yes.
ಮುಂದಿನ ದಿನಗಳಲ್ಲಿ ತಮ್ಮದೊಂದು ಇನ್ನೊಂದು ತರಗತಿಗೆ ನಾನು ನಿಮ್ಮನ್ನ ಇನ್ವೈಟ್ ಮಾಡ್ತೀನಿ ಸರ್.
Definitely, sir. Definitely, my pleasure it is.
Today talk on motional EMF. It's a very wonderful, informative talk on motional EMF. So, on behalf of KSTA and myself, thank you, sir.
Thank you, sir. Thank you so much. Yes, yes.
So,
thank you, students. Yes.
And I thankful to our Chief Executive Officer, Dr. Ramesh, sir. Thank you, sir. And I also thanks to our Managing Director, A.B. Basaraj, sir. And I thanks to our today's all the attendees. So, ಈ ಒಂದು ಬ್ಯಾಚ್ ಅಲ್ಲಿ ಸರ್ ಇಷ್ಟೊಂದು ಕ್ವಶನ್ಸ್ ಮತ್ತೆ ಇಷ್ಟೊಂದು ಇಂಟ್ರಾಕ್ಷನ್ ಆಗ್ತಾ ಇರೋದು ನಾನು ಇದೇ ಫಸ್ಟ್ ನೋಡಿದ್ದು ಸರ್. ಸೊ ತಮ್ದು ಕೂಡ ಪ್ರವಚನ ಅದೇ ರೀತಿ ಬಾರಿ ಕನ್ನಡ ಮತ್ತು ಇಂಗ್ಲಿಷ್ ಅಲ್ಲಿ ಎರಡು ನಿಘಂಟಲ್ಲೂ ಬಾರಿ ಸರಳವಾಗಿ ಅದು ಪ್ರಾಬ್ಲಮ್ಸ್ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡು ನೀವು ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥದ್ದು ಬಾರಿ ಉತ್ತಮವಾಗಿತ್ತು ಸರ್.
Yes, sir. Yes, sir. Yes, sir. Next time ಇನ್ನೂ ಟ್ರೈ ಮಾಡ್ತೀನಿ ಸರ್, ಕನ್ನಡದಲ್ಲೇ ಜಾಸ್ತಿ ಮಾಡಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತೀನಿ.
ಇನ್ನೂ ಒಂದು 10 ರಿಂದ 15 ನಿಮಿಷ ಎಕ್ಸ್ಟ್ರಾ ತಗೊಂಡ್ರು ತೊಂದರೆ ಇಲ್ಲ ಸರ್. ಯಾಕೆ ಮಕ್ಕಳುಗಳಿಗೆ ಈ ತರ ಒಂದು ನೀಟ್ ಮತ್ತೆ ಸಿಇಟಿಗೆ ಪೂರಕವಾಗುವಂತ ಕ್ವಶನ್ಸ್ ಗಳಿದ್ದಂತ ಸಂದರ್ಭದಲ್ಲಿ another 10 to 15 minutes, no problem, sir.
Yes, sir. Next time extend ಮಾಡ್ತೀನಿ ಸರ್. No issues.
Yes, thank you. Once again, I thank to you, sir.
Yes, sir. Thank you, sir. Thank you.
So thanks to all of you.
Yes, sir.
ಸೊ ನಾಳಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಡಾಕ್ಟರ್ ಸಾಂಬಕುಮಾರ್ ಅವರು ಹುಲಿಗಳ ಸಂರಕ್ಷಣೆ ಮತ್ತು ಯಾವ ರೀತಿ ಅದನ್ನ ಕಾಡಿನಲ್ಲಿ ಇದು ಮಾಡ್ತಾರೆ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ನಾಳೆ ಉಪನ್ಯಾಸ ನಡೆಯಲಿದ್ದು, ತಾವು ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಲ್ಲಿ ಇವತ್ತು ಯಾವ ರೀತಿ ಹಾಜರಾಗಿದ್ರು ನಾಳೆನೂ ಕೂಡ ಇದೇ ರೀತಿ ರಿಸೋರ್ಸ್ ಪರ್ಸನ್ ಜೊತೆ ಇಂಟ್ರಾಕ್ಷನ್ ಆಗಿ ಕೆಲವು ಏನೇ ಇದ್ರು ಆ ಟಾಪಿಕ್ ಮೇಲೆ ಕ್ವಶನ್ಸ್ನೇ ಆಗಲಿ ಇನ್ನೊಂದೇ ಆಗಲಿ ಇಂಟ್ರಾಕ್ಷನ್ ಆಗಿ ಕೇಳಬೇಕು ಅಂತ ಮತ್ತೊಮ್ಮೆ ನಮ್ಮ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿಯಿಂದ ತಿಳಿಸುತ್ತಿದ್ದೇವೆ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಟು ಆಲ್ ಆಫ್ ಯು ಸರ್.
Thank you, sir. Thank you.